Okay, so this is our third lecture, ODE. So the case 3, reduction of order, to solve linear ODE. So in this case, a homogeneous linear ODE is of the form y double dash plus p of x y dash plus q of x y is equal to 0. So this is very important because here our equation is in linear form, standard form. Okay, so our ODE must be in the standard form. If it is not in standard form, we have to convert it into standard form. Okay, so in this case, if one solution is given, suppose one solution y1 is given, then we can find the second solution y2. Okay, so if we know one solution, we can find second solution, and we will get two solutions, and we can write the general solution y equal to c1y1 plus c2y2. So if we know y1, then the second solution is given by the equation y1 integral u dx, where u is equal to 1 by y1 square e raised to minus integral p dx. What is p? P is coefficient of y dash. Okay, so this is u. So if we know one solution y1, we can find y2 is equal to y1 into integral u dx, where u equal to 1 by y1 square e raised to minus integral p dx, where p is this. So now we will solve a problem. From the notes. Okay. So we have given first problem is solve x y double dash plus 2y dash plus xy is equal to 0, given that y1 is equal to cos x by x is a solution. So here given one solution, y1 is equal to cos x by x. Now we have to find out the second solution y2. If we know second solution, we can write the general solution as cy1 plus c2y2. Okay. So first of all, we have to convert this into standard form, right? So this is not in the standard form because the coefficient of y double dash is not 1, it is x. So what we will do is we will divide all equation by x, then we will get y double dash plus 2 by x y dash plus y is equal to 0. So this is very important. We have to convert it into standard form. Now here p is coefficient of y dash. So p is equal to here 2 by x. And we know that y1 is given cos x by x. Now we can find u, right? U is by definition this 1 by y1 square integral, e raised to integral minus p dx. So this is 1 by cos x by x all square into e raised to integral minus 2 by x dx, which is equal to 1 by cos x by x square is equal to x square by cos square x. So it's reciprocal, right? Into integral e raised to minus 2 is constant, integral 1 by x is log x. So this is equal to x square by cos square x e raised to minus 2 log x is log x raised to minus 2, which is equal to x square divided by cos square x into log that is equal to 1 by e raised to log x raised to minus 2 is x raised to minus 2, which is 1 by. So now we can cancel out these two and I will get 1 by cos square x. So u equal to 1 by cos square x. Now y2 is equal to, we can write it by definition, y2 is equal to y1 integral u dx. So y1 is cos x by x integral 1 by cos square x dx, which is equal to cos x by x. 1 by cos square x dx is, so this is equal to cos x by x. 1 by cos square x is 6 square x. Integral 6 square x is tan x, right? This is equal to cos x divided by x into tan x is sin x by cos x is equal to, you will get sin x by x. So y2 is equal to sin x by x. So we get y1 and y2. Therefore, y is general solution is c1 cos x by x plus c2 sin x by x. Okay. So similarly, we can write this same equation. Okay, you just try to find. If one solution is given as sin x by x, then you can do the same procedure and you will get the second solution as cos x by x. So this is how we can find one solution if other solution is given. Okay. So anybody have any doubt? Any doubt? So next we will move into very important section, solving homogeneous ODE with the constant coefficient. Linear homogeneous ODE with the constant coefficient. So what you mean by constant coefficient? Constant coefficient means the coefficient of derivative of y's. This is a0, a1, etc. These are constants or numbers, and that also we have equation is linear. So I will write, first of all I will write what is the general equation ODE. So a differential equation of the form a0 d power n y divided by dx power n, that is nth derivative of y, plus a1 d power n y divided by dx power n minus 1 d power n minus 1. So n minus 1th derivative, etc. a n y is equal to r of x. Okay, so this is not this is the general form of a nth order ordinary differential equation, linear ordinary differential equation, because with a constant coefficient, because coefficients of these equations are constants. There a naught, a1, etc. an are constant, and r of x is a function of x. So if r of x is 0, then it is homogeneous. If r of x not equal to 0, it is non-homogeneous. So now we have to find the solution. What is the solution of such equation? Such equation for no homogeneous equation. So if r of x equal to 0, we have to find out what is the solution. Okay. So what will be the general solution? For that, what we will do is, so I can write, I am writing equating LHS to 0. a naught d power n y dx power n plus etc. a n y is equal to 0. So this is homogeneous ODE, linear ODE. Okay. Now I can write this as a symbolically. This as so we have a naught d power n y dx power n plus a1 d power n minus 1 divided by dx power n minus 1 plus etc. an minus 1 dy by dx plus an y is equal to 0. So this is general form of a homogeneous nth order ODE. Okay. Now I can write it symbolically as this. So a naught d power n means nth derivative of nth derivative plus a1 n minus 1th derivative plus etc. an of y is equal to 0. I can write it. That means a naught t power n y means t power n y means nth derivative of y. Okay. So I can write this as symbolically as where d is d by dx. D power n is d power n by dx power n. Okay. Now what we will do is, now we have to find out a solution for this ODE. So while inspecting this equation, we know that this is something constant times derivative of some function plus constant times n minus 1th derivative of some function plus etc. is equal to 0. That means derivative of that function may be some multiple of the same function. So our unknown function y of x is something like a derivative of that function. Some of the derivatives of that function is some multiple of that function. So we can guess what we will guess is we know such a function, that is if we take y equal to e raised to mx, we know that derivative is y dash is m times e raised to mx, that is multiple of same function. So that's why we are guessing, just guessing that that y equal to e raised to minus mx be a trial solution of this equation. So what we are guessing? We are guessing y equal to e raised to mx be a trial solution, and we don't know what is m. Now we will apply this. So what will be y1 first derivative? E raised to mx derivative, anybody? What is nth derivative of e raised to mx? Y equal to e raised to mx. What is first derivative? Y1. Anybody?
M e raised to m.
M e raised to mx. Similarly, second derivative, I am denoting y2, y double dash. This is m square e raised to mx. Similarly, nth derivative is yn. Nth derivative is m raised to n e raised to. So then what I will do is I will apply this. That means I will replace derivative by e raised to m. So a naught, I will get a naught e raised to mx into m raised to n. So I can replace this by this. So I will write here replacing. We will get a naught in equation number 3. Okay. A naught d power n y is nth derivative of y, that is m raised to n e power mx plus n minus 1th derivative is a1 m raised to n minus 1 e raised to mx plus etc. last yn a and y that is e raised to m. So I can take e raised to mx as common into a naught m power n plus a1 m power n minus 1 plus etc. an e raised to an is equal to 0. So this is product of e raised to mx into this polynomial. This is a polynomial in m, right? Polynomial in m. So that product is equal to 0, and we know that e raised to mx never is equal to 0. Why? Because exponential function never takes the value 0. So product of two numbers, you know that a into b equal to 0 implies either a equal to 0 or b equal to 0. Product of two numbers is 0, then either one of them must be 0. But we know that e raised to mx may not be 0, never 0. So the only possibility is this polynomial in m is 0. So this is equal to a naught m power n plus a1 m power n minus 1, not m minus 1, n minus 1, etc. an equal to 0. So this equation is called a characteristic equation or auxiliary equation. So how to find out m? What is m here? Value of m, and how many values there must have. So we get auxiliary equation a naught m power n plus a1 m power n minus 1 plus etc. an equal to 0. So this is a polynomial with a degree n, right? And in m. Now tell me, what is the value of m? What will be the value of m? And how many values must there have? A polynomial of degree n, how many roots there must have? Anybody? How many values that satisfies a polynomial of degree n? Okay, for example, if x square plus 2x plus 1 or okay, 0. This is a polynomial of degree 2. How many roots are there? Polynomial of degree 2 എത്ര root ഉണ്ടാവും? Anybody? Quadratic equation, how many roots are there?
Two.
2 roots, right? This is 1 1. So similarly, this is a polynomial in degree n, and instead of x here m. So how many values are m there must have? N values, right? N solutions. So we can get m equal to m1, m2, etc. mn solutions. So this is a polynomial ODE of degree n. Then we can write y equal to c1 e raised to m1 plus c2 e raised to m2, sorry, m1x, m2x plus etc. c3 cn e raised to mn. So there are n roots. Then this will be the general solution. So there are few problems because this root this is a polynomial, then the root may be real, distinct, and may be complex. So there are three cases for the roots of characteristic equation. If we know the root, we can find the solution. Anybody have any doubt? So if we know the root, we can just find the solution. Okay. So we got a polynomial of degree n, and there may have n roots. And first case one is when the roots of the equation are real and distinct. That means all roots are real and distinct. That means let m1, m2, etc. mn be the roots, and they are real and distinct root. Then the general solution is c1 e raised to m1x plus c2 e raised to m2x plus etc. cn e raised to mnx. So we can directly write the solution of linear ODE as roots. If we have n distinct roots, c1 e raised to m1x plus c2 e raised to m2x plus etc. Now, okay. Now next, if some roots are repeating, okay, when the auxiliary case 2 is when the auxiliary equation, roots of the auxiliary equation has two equal roots. That means m1, suppose m1 equal to m2 equal to m, and all other real roots are real and distinct. So that means we have two roots, m1 equal to m2 equal to m, and all other roots are real and distinct. Then the solution is of the form, two roots are distinct. One is c1 e raised to mx, that is first. Then second solution we can write c2x into e raised to mx. Okay. So if the roots are repeating, c1 e raised to mx is one root, one solution, plus c2x e raised to mx is other solution, and there are n distinct, c3 e raised to m3x etc. up to cn e raised to mnx. Now in general, if r roots of the auxiliary equations are equal to m1, that means first r roots m1 equal to m2 equal to etc. mr equal to mr equal to m for m1, all first r roots are equal and all other roots are distinct, then we will write y equal to c1 plus c2x plus c3x cube plus etc. cr x raised to r minus 1 e raised to m1x plus cr plus 1 e raised to mr plus 1x plus etc. So what we have to do, if roots repeat ചെയ്യുന്നുണ്ടെങ്കിൽ നമ്മൾ എന്ത് ചെയ്യാം? If it is repeating 3 times, our solution is c1 e raised to mx plus c2 x e raised to mx plus c3 x square e raised to mx. If it is repeating 4 times or 5 times, we will add up. Okay. Now case 3 is if it has complex roots. Suppose alpha plus ib and alpha minus ib are two complex roots, and m1, m2, etc. mn are m3, m4, etc. mn are real and distinct roots. Then solution is of the form, if there is complex roots, e raised to alpha x cos a cos bx plus b sin bx. Okay, that is the solution. Why? Because e raised to alpha plus I beta. This is actually equal to e raised to alpha into cos beta x plus sin beta x. Okay. I sin beta x. We are not using complex, so raised to alpha x. Okay. So instead of that, we will write e raised to x or a cos beta x plus b sin beta x. We are not taking I. Okay. C3 e raised to m3x plus etc. Similarly, if complex roots are repeating, we will do problems, then we will learn. Okay. So if complex roots are repeating is a multiple of k roots, then we can write solution as e raised to alpha x is there, a1 plus a2x plus etc. akx raised to k minus 1 cos beta x plus b1 b2x plus etc. pkx raised to k minus 1 sin beta x plus the other real and distinct solution. Okay, there is a note. Now that is the general form. Now first we will do second order ODE. Okay, second order ODE, then equation is of the form a naught d square y by dx square plus a1 dy by dx plus a2y is there. A2y is equal to 0. Then you can write a naught d square plus a1 d plus a2y is equal to 0. Then in order to get the characteristic equation or auxiliary equation, what we will do is put d equal to m here. Then I will get a naught m square plus a1 m plus a2 is equal to 0. Then you can find this solution of this equation, and we will continue. If m1 and m2 are two real roots, then the solution is of this form. If the m1 and m2 are repeated roots, then the general solution is of this form: y equal to c1 plus c2x e raised to mx. If it has a complex root, then the solution is of the form e raised to x c1 cos beta x plus c2 sin beta x. Now we will do a problem that so we, okay. So find it. First problem, find the general solution of y double dash minus y equal to 0. So listen carefully. Here our solution is y double, sorry, equation is y equal to 0. Now first of all we will write in the symbolic form. Y double dash means d power d square second derivative minus y 1 into y is equal to 0. This can be written as d square minus 1 y is equal to 0 because uh, d square y minus y equal to 0. Then what we will do is put d equal to m. Then we will get the uh, auxiliary equation. So put d equal to m. Then auxiliary equation is m square minus 1 is equal to 0, which implies what are the roots of m square minus 1? M square equal to 1, m equal to plus or minus 1. So the roots are 1 minus 1. Okay. So what are the values of m? 1 and minus 1. Both are real and distinct. Okay. Both roots are real and distinct. Then we can write y equal to c1 e raised to mx 1x plus c2 e raised to minus 1x. So this is the solution. Okay. So in next class we will do more problems. Please go through this topic.